Welcome to the subject Business Intelligence. Today's session is session number 20 and the topic is data models for OLTP and OLAP. So topic is data models for OLTP and OLAP. First we will study data model for OLTP, that is online transaction processing. Point number 1. An OLTP system usually adopts an entity relationship (ER) model, whereas an OLAP system, that is online analytical processing system, adopts either star or snowflake model. Students, in last year we have studied entity relationship model in database management system subject. Same model follows here for online transaction processing system. Whereas for online analytical processing, a model such as star or snowflake model is there. So these are two different models that you will learn in this subject, that is star and snowflake. Data model for OLTP. Figure 3.5 given in the next slide, and also this 3.5 figure is sent with the PDF file, depicts an entity relationship, that is ER, data model for OLTP, that is online transaction processing. In this model, we shall consider the following three entities. Students, you have studied ER model in the database management system. It is going to be repetition for you, but it is important. So three entities are employee, employee address, and employee pay history. In employee ID is the primary key. You know, student, there is a primary key for every table or every entity. Employee address, point number 2. Employee ID is a foreign key referencing to the employee ID attribute of the employee entity. So what is primary key in the employee table is going to be foreign key in the employee address. This is very clear. Point 4. Employee pay history. Employee ID is a foreign key referencing to the employee ID attribute of employee entity. So again, in the employee pay history table, employee ID is going to be the foreign key. This is what we learnt in DBMS last year. Student, this is a table which is very clearly sent with the PDF file. Here we are going to study employee table, okay, which will have employee ID, national ID number, contact ID, manager ID, title ID, birth date, marital status, like this. Okay, so here employee ID, which is shown as a key, is a primary key. So all this correct figure is sent with the PDF file. You please note from that. Now let us take data model for OLAP. A multidimensional model can exist in the form of star schema or a snowflake schema or a fact constellation or galaxy schema. So there are three different types of multidimensional table. Okay, that is star schema, snowflake schema, and facts constellation or galaxy schema. Students, in point number 2, here we shall consider only two models, that is star and snowflake. Point number 3. To understand star and snowflake models, we must know the meaning of two terms, that is dimension and fact. So students, to understand star, we must know okay, what is meant by dimension and what is meant by fact. So we'll study dimension with respect to OLAP data model. Dimension. In general, a dimension is a perspective or entity with respect to which an organization wants to keep records. Point number 2. For example, all goods store wants to keep records of the all goods store wants to keep records of the store sale with respect to time, product, customer, or employee. So they want to keep records with respect to time, product, customer, and employee. These dimensions allow, point number 3, to keep the track of things such as quarterly sales of the products, the customer to which products were sold, and the employees of the store who were involved in materializing the sales. So who were the employee, okay, working when this sale was going on. Point number 4. Each of these dimensions may have a table associated with it called the dimension table. Point number 5. A dimension table such as product may have attributes like product name, product category, and unit price. Fact, the meaning of fact. Fact with OLAP data model. So what is fact? Point number 1. Fact. Facts are numerical measures or quantities by which we want to analyze relationships between dimensions. Point number 2. For example, facts are total sales amount in dollar, quantity, that is number of units sold, discount, that is amount in dollars of discount offered, etc. Now we'll consider star model. Figure 3.6 sent with the PDF file depicts the star model for OLAP. Students, for this you have to refer PDF file where I have sent the picture that is 3.6. Point number 2. This model has a central fact table which is connected to 4 dimensions. Point number 3. Each dimension is represented by only one table and each table has a set of attributes. Sunflake model. Student, star model is similar to star, okay, and sunflake model is similar to sunflake, that is sun's picture you can see. Point number 1. The snowflake schema, figure 3.7 sent with the PDF file. There is a central fact table connected to 4 dimensions. So in the center you find fact table and 4 dimensions are connected to the 4 corners of this fact table. Point number 2. The product dimension is further normalized to product category dimension. So product table is further connected to or normalized to product category table. Point number 3. Similarly, employee dimension is further normalized to department dimension. So employee table is connected to department table or it is normalized. Point number 4. The normalization of the dimension tables definitely helps in reducing redundancy. So students who have studied in database management, normalization is a process for reducing the redundancy. However, it adversely impacts the performance as more joins will be needed to execute a query. Students, so I sent PDF file. Now with this video, I think you will be able to understand what is model for OLTP. For OLTP, we adopt ER model, whereas for OLAP, analytical processing, we adopt, okay, stars model or sunflake model. Please write it in your notebook, okay, and study. Thank you.